Right, we're looking at exercise 703, linear modelling. Y equals mx plus b is called a linear model, and the reason it's called a linear model is if it's like y equals 2x plus 4 or something, it forms a straight line. That's why that's called a linear model. Now, with this equation, every time you write up an equation, something equals something else, you will have a dependent and an independent variable. Now, dependent is the value of this depends on what I put in there. That's how I think of it. So, don't you normally have, for example, the subject of the formula? The value that you get for y depends on what you substitute for x. Does that make sense? You know, like if I have, for example, y equals 2x minus 4. I'm going to say when x is 0, y is this. When x is 1, y is that. When x is 2, y is that. So the value of the y depends on what you're substituting for x. So the value of y depends on what x is. So y is the dependent, x is the independent. Okay? So I'm going to write here, because the value of y depends on the value of x that you choose, y is called the dependent variable. The dependent variable is basically what's the subject of the formula, the one out the front, okay? And x is called the independent variable. So y equals 2x minus 4 was the example we were looking at. So we know that x-axis is the horizontal or vertical axis. Yeah, there's the horizon. And y is the vertical axis. Therefore, we always put the independent variable on the horizontal axis, and we always put the dependent variable on the vertical axis. Okay? Always dependent variable on the vertical axis, independent on the x-axis. Okay? Now, the gradient of a linear function, we've been talking about gradient for like a week now, is the rate of change of y with respect to x. You know, we did change in y values over change in x values. And also, we also spent a lesson saying, oh, the y values go up by, what do they go up by here? 5. Now, why am I allowed to say, yes, the y values go up by 5 here? Because my x values only go up by 1. See, my x values here are going up by 1. So that's just a normal unit, 1. So if your x values are going up by 1, you can see the gradient from a table of values straight away. Okay? So you check. If my x value goes up by 1, so if x goes up by 1, the gradient is always what the y values go up by. Now, we did a lesson on this. But if you want to use that method and say, yep, y goes up by 5, the x's have to go up by 1. Otherwise, you can't use that method. All right? So, basically, the rise is 5 for every 1 that the x's go up. So, it's 5 over 1. So, remember, we did this the other lesson. What would be, tell me what the equation of this line is. Y equals, what's the gradient? Remember, 5x, it's mx plus b. The gradient is 5. And what's the y-intercept? It's negative 4. So the equation of this line is y equals 5x minus 4. Remember, it's y equals mx plus b. The m here is 5. I check. If the x's go up by 1, and they do, then the gradient is what the y's go up and or down by. And they go up by 5. And if I've got x is 0, I can read off the y-intercept. Okay? So, and I wrote this before, but I'll write it again. The y-intercept is the value of y when x is 0. Okay? One final point is, so we already spoke about this, the y-intercept is the value of y when x is 0. So we can see the y-intercept there, it's -4. But another thing is, you know that the bigger the gradient, the higher the gradient, the steeper the line. See, this goes up by 5. That's a big gradient. But if it only went up by 1, that's a smaller gradient, and the line would not be so steep. So the higher the gradient, the steeper the line, and the faster y increases relative or with respect to x. Okay? This y is going up a lot faster than the x. And when that happens, see, x is only going up by 1. But the y's are going up by 5. So that's a big gradient if the y is going up a lot faster than the x. But if the x's go up by 1 and the y's go up by 1, then the gradient's only 1. Here the gradient is 5.